guys, April 26th through the 30th. This is lesson number 31, using trigonometry to determine area. Alright, so make sure you have that lesson out in front of you. Our goal is to prove that the area of a triangle is 1/2 times the product of two side lengths times the sine of the included angle. And we're going to solve problems using this formula. Another thing we're going to do in this lesson is to find the area of an isosceles triangle given the base length and the measure of one angle. Alright, so let's go ahead and hit it head on, looking at our opening exercise. 3 triangles are presented below. Determine the area for each triangle, if possible. If it is not possible to find the area with the provided information, describe what is needed in order to determine the area. Alright, so let's look at triangle ABC. How do I find the area of a triangle? 1/2 base times height. Alright, so my base. So for triangle ABC, I can do 1/2 times the base times my height. Alright. So I get 1/2 times 12 is 6. 6 times 5 is 30. And since we are doing area, it is square units. Alright. Looking at the second triangle, for triangle DEF, once again, base times height. So 1/2 times base times height. 1/2 of 20 is 10. 10 times 8 is 80 square units. Alright. Now let's look at the triangle GHI. Can I find 1/2 base times height? I do not have the height, and there's not enough information to find the height. So we cannot find the area of that triangle. Is there a way to find the missing information? Without other information, there's no way to do this. Triangle were provided. Is it possible to determine the area of the triangle now? So find the area of triangle GHI. So they have given us the third side of the triangle. Alright, so how can we find the height of our triangle? Well, the height would be dropped right there. So now I have created right triangles. Alright, so I want to figure out this right here. I can I figure out what the bottom is? Well, guys, here's what I can do. And I put X. Let me do this. I'm going to change this. I don't want to label that X. Because this right here would be 15 minus X. I can't divide it in half because my height does not divide it in half. But it does divide it into X and then 15 minus X. Alright? So, I can figure out my height here by using the Pythagorean theorem. I'm going to start simple, and I'm going to use this triangle over here. Alright? because that's our height. Pythagorean theorem, a squared plus b squared is equal to c squared. So x squared plus h squared is equal to c squared, 49. Okay, now I'm going to fix this because I'm trying to find my h. So I'm going to subtract x squared from both sides. Okay, now I still can't solve this because I have two variables. So I'm going to have to set up another system. So I'm going to have to use this other triangle here. Alright, so we're going to do it like this. So this is triangle 1. We're going to let this be triangle 2. Alright, so h squared plus 15 minus x squared is equal to 12 squared, which is 144. Alright, so I'm going to subtract this 15 minus x squared. So I get h squared is equal to 144 minus 15 minus x squared. Alright, now I can go ahead and simplify this. Let's get what we can out of there. So I get 144 minus, so negative x squared times negative x squared, negative x times negative x is x squared. Negative x times 15 is negative 15, and I have to do that twice. So negative 30x. And then 15 times 15, if you don't know your perfect squares, then that might be a time to remember those. So I get 225. Alright? And then I'm going to go ahead and simplify this. I get h squared is equal to negative x squared plus 30x. And now I've got negative 225 plus 144, which is negative 81. Alright? Alright. So I'm going to set these equal to each other because h squared is equal to both of them, and then I can solve it. So I get 49 minus x squared is equal to negative x squared plus 30x minus 81. When I take my x squared over, they zero out. So I have 49 is equal to 30x minus 81. Alright? I'm going to add 81 to both sides. And I get, 130 is equal to 30x. Alright? Divide by 30. And this is what I get. I can divide both of those by 10, and I get 13 over 3. So I know that my height is 13 over 3. Alright? I also know that GJ is 13 over 3. Alright? Alright. So the value of x can then be substituted into either of the expressions equivalent to h squared to find the height. Alright? So, sorry, I mislabeled that. This is 13 over 3, and HJ would be 13 over 3. But now I've got to figure out what my height is. So h squared is equal to, and I would choose the smallest of them. Alright, so I get 49 minus 13 over 3 squared. Alright, so that's 49 minus, what, a 169 over 9. Alright, if I work that out, so 9, let's just do this. 169 divided by 9 is 18. Alright, so 18 times 9 is 162, so that's 18 and 7/9. I need to subtract that from 49. Alright, so I'm at 49, or 48 and 9/9. Sorry guys, you can't see that. The glare on it's horrible. So I have 2/9, so I get 30 and 2/9 left over. 9 times 30 is 270. 272 over 2, or 272 over 9. Alright, and I have to take the square root of that. When I figure this out, it all is said and done, it comes out to 4 square root of 17 over 3. So now I have the height. So since I have the height, and I don't know why they don't give us enough room, because we have a lot of stuff that we have to do here. Since we have our height, we can now do 1/2 base times height. Alright? So when I multiply all of that out, I get 10 square root of 17 as being my area. Alright? Alright, example number 2. Well, we got to do a couple of things before we do example number 2. So let me kind of move that over. Alright, so example number 2 is a little bit different. So let's consider triangle ABC. Alright. Which is set up similarly to the triangle in example number 1. Alright. This is B. This will be A. Write an equation that describes the area of this triangle. Well, it would be 1/2 times A times H. Alright? So, let's kind of talk about this for just a second. We're going to rewrite this equation, and we're going to talk about what we see. Alright, so area is equal to 1/2 times A times H. Pay attention to what I'm doing. B over B is the same thing as saying what? 1. So it's being multiplied by 1. Alright? what happens here. Now I'm rearranging. Alright, now I'm rearranging. I've rearranged my statement, but my value stays the same. Okay? So now I want to modify my diagram for just a moment and base it off of this third line here. What if I now say that my angle here, alright, so we're going to now modify this to my arc angle is going to be marked at vertex C. What do you notice about the structure of H over B? Opposite over hypotenuse. Okay? Or sine of my angle. Can we think of this newly written area formula in a different way using trigonometry? Well, so now what if I say 1/2 AB times the sine of my angle? Okay? All I'm doing is replacing this H over B, which we said was sine, by the sine of my angle. If the area can be expressed as 1/2 AB times the sine of my angle, which part of the expression represents the height? Alright? Well, my height would be equal to B times the sine of my angle. Remember? My height was B. So I'm going to take B times the sine of my angle. So compare the information provided to find the area of triangle GHI in the opening exercise. How the information changed in example 1 and then change again to the triangle above for triangle ABC. Well, if we go back and look at the triangle in example number 1, they want us to find GHI. How is this similar? Okay, so we're comparing information here. How is this similar to example number 1? Well, in example number 1, or in the opening exercise, we had the measure of all 3 sides, but we couldn't find the area because there was no height. Alright? I'm sorry. In the opening exercise, one of these we couldn't do because we had no height. In example number 1, we were able to find the height even though we didn't have that. Alright? So we can apply the Pythagorean theorem in 2 layers. Alright? So basically we've got to make sure that we have enough information. So let's look at example number 2. A farmer is planning how to divide his land for planting next year's crops. A triangular plot of land is left with 2 known side lengths measuring 500 meters and 1,700 meters. What could the farmer do next in order to find the area of the plot? Alright, so with just 2 side lengths known, what are the farmer's options to determine the area of his plot of land? Well, he can either measure the third side, apply the Pythagorean theorem to find the height of the triangle, and then calculate the area, or he could find the measure of the included angle between the known side lengths and use trigonometry to express the height of the triangle and then determine the area of the triangle. So let's kind of draw this out. Alright, so he has this 1700 here. One side, the left, with two known side lengths of 500 and 1700. Alright. So, what could he do? Now, we weren't given an angle, but he could figure out the angle. Alright. So, let's say that the angle is 30. What can I do? Well, we literally just said that we can do 1/2 times my base times my side times the sine of 30. Alright? So if I do that, let's go ahead and figure this out. So 1/2 of 500 is 250. So 1700 times 250 gives me 425,000 sine of 30.
Pardon the interruption. Jaden Fryman to the office, please. Jaden Fryman to the office.
And then we're going to see what that sine of 30 would equal. And this is what I have. So the area would be approximately 212,500 square meters. Alright. Sorry guys, my camera, I don't know what's going on with it. It moves and I try to make sure I have the paper in view. Alright, so exercise number 1. A real estate developer and a surveyor are searching for their next piece of land to build on. They each examine a plot of land in the shape of triangle ABC. So part A is to draw a diagram and model. So we've got triangle ABC. The real estate developer measures the length of AB and AC and finds them to both be approximately 4,000 feet. So 4,000 feet. Okay? And the included angle has a measure of approximately 50. So the included angle here would be 50. The surveyor measures the length of AC and BC and finds the lengths to be approximately 4,000 feet and 3,400 feet, respectively, and measures the angle between the two sides to be approximately 65. Alright, so draw a diagram that models the situation, labeling all lengths and angles measures. So I did that as we went. Okay? So the real estate developer and surveyor each calculate the area of the plot of land and both find roughly the same area. Show how each person calculated the area, round to the nearest 100. Redraw the diagram with only the relevant labels for both the real estate agent and the surveyor. Alright, so let's talk about how they could have done this. Well, so the first thing they could have done is they could have drawn an altitude straight down. Alright? With that being said, my side still says 3,400 and 4,000. And all I have to do is I can look at this being my included angle and do 1/2 times 4,000 times 3,400 sine of 65. So 1/2 of 4,000 is 2,000. Alright, so I've got 2,000 times 3,400 times the sine of 65, which gives me approximately 6.16289 times 10 to the 6th power. So I'm going to round that to approximately 6,162,893. Alright? And they were measuring, I believe, in feet, so square feet. Let's talk about another way that they could have done this. Alright? Another way that they could have done it was drop an altitude from another triangle, or from another vertex. Alright, so they could have done an altitude that way. And if that's the case, then I'm kind of looking at my triangle like this. Alright. So now I could do 1/2 times 4,000 times 4,000. Oh, and I forgot to put my angle here. We said was 50. Alright. So times the sine of 50. So when we enter that into the calculator, so I have 2,000 times 4,000 times the sine of 50 gives me approximately 6,128,356. So if you will look, they are very similar. They're a little off, but very, very close. What could possibly explain the difference between the real estate agent and the surveyor's calculated area? It can be accounted for the approximation of the measurements taken instead of exact. So the measurements weren't exact. Alright? Because if you remember back up in your paragraph, it says approximately. So since our measurements weren't exact, then it probably caused a little bit of a difference. Alright guys, that's lesson 31. Hopefully you didn't find it too difficult. Making sure you have that calculator handy. Have a great day.